sure, but Monday I'm pretty sure Nick said that he is coming today. He emailed that I'm just going to study and collect questions for Monday.
Okay.
And I am asking,
I think Alyssa said she's not here today and Monday.
that's okay, I mean, I can only think of one or two person having the same questions that are listed. I cannot think of everybody having the same question. So, it's just to, why is it? Okay. Try again in a few minutes. Yesterday afternoon, I know I drafted the email, but even late night I noticed the email did not go out. Yesterday afternoon, something was wrong with either Canvas or and or both Canvas and the internet for a brief, maybe 2 hour period. I couldn't post anything until 3:30 or 4 o'clock. Um, Test one. So just because no one is here, I probably can turn it on.
Oh, you don't want it?
No, I don't need it.
Oh.
Just let me know the other two when we get to it.
Oh, okay.
Anyway, this is the so-called middle question, 3 spiders,
Oh, okay.
the one which is listed there. And probably this will be a trouble. You do want to record it, I cannot post it.
Okay.
This is
Oh, this is Brady's?
Yeah.
Oh, how cool. Okay.
So
Yeah, that's right. She showed me. She's like, we had the wrong.
So I cannot post it anymore.
I understand. Okay.
Anyway, I don't know if you get to see the question, but
Yeah.
you can access it on WebAssign. The question is essentially what is the force on number 3, and number 3 is one which is on the right. So I will write down which part of the chalkboard is.
That's good.
This is
Yeah.
good?
Mhm.
Okay. So one here, and if you notice the comment, which is how do you find the magnitude of the electric force? So the rest of the class or explanation, I'm not talking to either one of you. 1, 2, and 3, just because how do you find it? 2 positive, and we are interested on the force on number 3, so repulsion that way, and on 3 by 2 is going to be an attraction this way. So I can label the forces, but next comes the part where one actually will have to look at number 1 and number 2 and number 3, what the charges are. So I will write down just the number, not the microcoulomb part. And this is also accidentally 6.9. And we want to notice that these 2 charges are same in magnitude. So call this force number 2, call this force as number 1. Because the distances are equal, we actually should be able to guess that the 2 forces are same in value. And once that is the case, the other thing to notice is the not that good, that being very symmetric, the angles are same. So little bit of conceptual jump, which is the 2, so to say, vertical components, they are going to survive, but the 2 horizontal components are going to cancel one another out. So the net force essentially is going to be two times either 1 or 2, doesn't matter, sine of theta, and that is where comes what is the angle theta. Theta is the angle either one of these forces is making with respect to the horizontal line. So, as far as, do you catch the audio too?
Yeah.
Okay. So as far as what is left goes, it's what is the value of F1, maybe for you over here, it's K Q1 Q2 divided by R squared is the Coulomb's law. So number-wise, K is a constant, 9 into 10 to the power microcoulomb, 2 of them. And finally comes what is R, and that is going to be A in this case. A is given to us 0.56, so 0.56 square. So that is going to be either F1 or F2. They are equal in value. And then comes what is sine theta. So a little triangle probably is going to tell you what the angle is going to be equal to. And that is possibly the second challenging part other than taking components. And sine theta is going to be equal to A over 2 divided by A or half. So rest of it goes back in the expression to calculate the magnitude of the force. There are 2 other questions listed, 1 and 3.
Yes. Test 2, number 14, the Group of Friends National Park.
Group of Friends National Park.
Oh, but wait, you're still on test 1? She had 15. Earth and cloud layer question.
Oh,
Yeah, that one. There you go.
well, based on this, this actually says your response differs from the correct answer by more than 10%. So I'm guessing it's numeric calculation error. Anyway, the area of the cloud layer is given to us. And the first question, what is the capacitance? So you said it is 15. Yeah, it is. Area is 4 kilometers squared. So I will say that a little later, and the spacing D is given to us as 800 meter. Capacitance is given by, for a parallel plate, epsilon naught times A divided by D. So we actually know what this constant is, 8.85 into 10 to the power minus 12. D is 800 meters given to us. The only question where plus I do see it, the number coming out to be 8 by 8, close to 1, 4 multiplied by 1. The number coming out to be what it is here. So probably it is something in the conversion that they have missed. And the second part of the same question is the electric field is given to us 3 into 10 to the power 6. And we want to find out what is the maximum charge. So for part B, Q is equal to C times V. We just calculated C, so you do need the value of C from the first part. But in this problem, since you are given what the electric field is, the electric field is electric potential divided by D, or in other words, the electric potential is electric field multiplied by D. So number wise, we'll just put this number 3 into 10 to the power 6 for electric field, 800 for D is what will go in here, and the C value is from the first part. So again, if you ask me, what do you see? Part B probably was done correctly, but 54 and 106, if you look at the answer in part A, approximately a factor of 2 is what they missed in the first conversion, and that translated as an error in the second. And the last one you said from
Is on test 2,
is on test 2.
number 14. Yeah, up. The Group of Friends National Park.
Oh. This one probably needs long work, but it's okay. This is one on Kirchhoff's rule. I don't know if you get the screen or not. Still, we can redraw the picture. I probably am going to need some more space, so okay, now one odd, does it say R1 or L? Let's keep the references same. R dead and RS. And it says EL and ED. EL and ED. They ask us to calculate the current through the starter motor, which is, I didn't put the switch in here. What is the current flowing here? We can take the current to be flowing from right to left, and they also ask us to calculate the current through the dead battery. We can take the current to be flowing like this, dead battery, and that is essentially where if and when I'm teaching physics to you, if and when we use the junction rule, dead coming in and I sub S going out, how much current is going to be flowing in here is absolutely up to you to label. On the other hand, while it may not be absolutely clear from this junction, I sub S coming into this junction and I sub D is flowing out. So the amount that is left is I sub S minus I sub D that flows out through here. This is to avoid introducing a third current, and once we assign the current, going around the circuit is absolutely up to you how you want to do it. We can just pick any two loops for simplicity, going clockwise, upper loop and lower loop, and for the upper loop, the loop equation is going to be pretending starting from the middle left corner. The upper loop equation is going to be E sub L as gain, and then I am going to lose R sub L multiplied by IS minus ID. It will look a little ugly very soon, and that is where the middle branch is complicated looking. Going against the current, I will gain voltage. Going from the positive to negative terminal, I will lose voltage. So, loss, voltage, and gain voltage. We want to set the loss and the gain to be equal. So, while very symbolic, I will come to the numbers very soon. Let me first write down the second loop equation. And the second loop is a little bit easier, and that is because as far as starting point goes, it could be anything. Let's again take the middle left top corner as the starting point. That is where we first gain E sub D voltage going clockwise, and then we are going to lose R sub D times I sub D. That is following the current, and also we are going to lose R sub S and I sub S coming coming back to the same point. So these are the two loop equations. And finally, just to make it look a little beautiful or better looking, we can put some numbers. I know you cannot probably read the screen or record it meaningfully, but you should be able to look up the numbers. As far as the battery voltage go, the live battery R sub L voltage is 12. So this number is 12. And the dead battery has a voltage of 10. So this is 10. R sub D has a value which is given to us 2.5, and R sub L has a value which is 0.01. So with these numbers, I'm just going to rewrite the same equation. 12 plus 2.5 I sub D and 0.01 I sub S, these are still not known, I sub D, and then this is 10 given to me. Looks a little better, that is cleaner. As far as the dead battery goes, this number is 10. We already know. R sub D is 2.5. So 2.5 goes in here. ID and R sub S. Oh, didn't put that in here yet. R sub S is 0.06 given to me. So 0.06 I sub S. So we have slightly cleaner looking equations. The rest of it is two unknowns, two equations solving for it. So if they have saved the paperwork, see if it matches or if there is a mistake.
No, they said if there's no questions on the final, like those three, they'd be happy.
Why they doesn't mean Brady said that?
Yeah, they spent a lot of time on those three.
Oh.
They were
Well,
tricky. For some reason, that was hanging Brady up, right, Brady? No, sit down. No, sit, we're not done yet.
well, I still don't know what is going to be there in the final, but I do know that there will be, should be, there always is something that average students can do. Certainly, so far, Brady is performing above average, so
Okay, that's good.
you should sleep well, or Brady and Chris.
Okay, that's good. That's helpful. That's good. All right. All right, there are two right-hand rules, you're saying.
Yeah, so now on, in case you show up on Monday, maybe
Okay.
it will be easier, partly because I'm not prepared with the graphics.
Oh, okay.
Maybe I can display the graphic on Monday.
Okay.
If it is public,
Sure.
I will just look up the general question.
Okay.
So Brady specific numbers are not going
Okay.
to be there, or
Okay.
what the responses were. But you can ask whoever sent questions too.
Okay.
I will make sure that I have pictures for both right-hand rule.
Okay, that sounds good. I don't think they'll have any other questions for Monday because they're not meeting today. So
Okay.
just that. That's all. I mean, they're going to meet on Monday. So I don't know if they would have any questions for Wednesday. I guess we'll see. But
Yeah, I mean, that's fine.
Okay.
Monday or Wednesday,
okay.
I'm still going to be here.
Okay. All right. All right, Brady. Oops. There's your blocks. All right. Then we're done. Okay. Thank you.